All right, hi everyone. Welcome to an introductory demo of Operator Builder. Operator Builder is a Kubebuilder plugin that accelerates the development of Kubernetes operators. In this demo, I'm going to show how Operator Builder works. And if you want to find out more about the project, you can go to GitHub at VMware Tanzu Labs Operator Builder, where you can open issues and pull requests and so on. So the demo I'm going to be doing today is based on a reference implementation that one of the developers on the team put together that walks through the generation of the source code for an operator builder, for an operator for the guestbook application in the Kubernetes docs. So we're going to essentially build an operator for this PHP guestbook application. So to be clear, what we're going to do is use Operator Builder to generate the source code for a working Kubernetes operator. And then I'm going to demo the functionality of that operator using a local kind cluster that I have running. So on this left pane, I have a watch on the directory tree. And in this directory, I am going to generate the source code for this operator using Operator Builder. So you can see right now I have several hidden directories that have various configurations in it, and a README file and nothing else. As I generate the source code with Operator Builder, you'll see the files show up on the left over here. This is a Go project, so I have to first just run go mod init to initialize the project. And you see a go.mod file show up on the left there. And we're now ready to start running Operator Builder commands. But first, let's just take a peek in the .source directory. This directory has all the configurations that I'm going to use to generate the source code using Operator Builder. All of these files, except the last one, are manifest for Kubernetes resources such as deployments and services and a namespace. And then this workload file here has the overall workload configuration values that we need to generate the source code. I'm actually going to go through and generate the source code and do a demo and then come back and have a look at these configuration files to demonstrate how we brought about the end result. So in order to do this, I'm going to run Operator Builder init, and then I'm going to use the workload config flag to pass in that .source workload.yaml file. And because I'm using Go version 117, I'm going to use skip Go version check here. And so we're initializing the project. You can see on the left here, we're starting to get some files show up. We get a README, a make file, a Docker file, some of the basic stuff that you'd expect. We get a bunch of Kubernetes manifests and customized overlays that facilitate the deployment of your controller manager to a cluster. And we have, of course, a main.go file that has our main package in it. And that is we have a compilable Go program at the moment, but it really has no functionality just yet. It's basically the skeleton of functionality at the moment. So in order to add that functionality, we're going to run the Operator Builder command again. This time, I'm not going to run the init command again. Instead, we're going to run the create API command. And we're going to pass in that same workload configuration, workload.yaml. And we do want a new Kubernetes, new custom resource, and we do want a controller to reconcile state for that resource. So I'm going to hit yes to both of those prompts. And it's going to generate the rest of the source code. And it is complete. And you can see all of the files that are additional files that have shown up here on the left. And we'll just take a quick tour through what we have here. The APIs directory, the first one at the top here, contains all of the source code for the definition of our new custom resource. It includes the definitions for the resources that will be created when we create a new guestbook application instance. Below that, we have a companion CLI. We won't get into that in this demo. We'll do that in a future demo. We have more configuration files that aid in the deployment of the controller manager. Under the controllers directory, we have the source code here in guestbook controller.go. That's the core logic for the reconciliation of guestbook types in this instance. And then under the internal directory, we have a bunch of packages that do specific things in the operation of this, of this operator. So what we're going to do now is, first of all, we're going to have a look in the config samples directory. And one of the things that gets generated for us is a sample custom resource. So this here is a guest book resource. And we have a custom API version here that we've created. We're going to call it guest book sample. And you can see these are the configuration values that we can pass in so that our controller will create an instance of a guest book application, which is a PHP front end and a Redis back end. And we can provide these values, such as the namespace that we want to deploy this application into. And the guest book replicas, the number of replicas that we want in that PHP front end, and so on and so forth. So we get a make file with several useful make targets. The first one we're going to use is make install. And what this is going to do is generate and then install the custom resource definition into the cluster so that our Kubernetes API will now recognize this guest book resource when we submit it. And you can see the last line down here says that our new custom resource definition has been created, which allows us to say kubectl get CRD, and we have our new guest book custom resource. The next make target we're going to use is make run. Now, what make run does is it compiles and runs the code locally, and then uses my kubeconfig to run against the cluster. It could be a remote cluster that you have in AWS or Google Cloud or whatever you like. In this case, I'm using a kind cluster, but the end result is the same. This is functionally equivalent to building a container image for our controller manager and deploying it into the cluster. But I just don't have to go through the steps of building the container image and then making the image available in the cluster and whatnot. So it's just it's a convenience for development and for demo purposes, for that matter. In this top left pane, I'm going to run kubectl get pods for this guest book application namespace. That guest book, if I come over here, kubectl get namespace, you can see that we don't have a guest book application namespace just yet. When we submit this guest book resource to the cluster, our controller manager, which is running, you can see the log output from the controller manager in the bottom left here. You'll see that it recognizes this guest book and it'll create the namespace and the deployments and the services that we need in order to create an instance of this guest book. So I can run kubectl apply fconfig samples, and I'm applying this resource up at the top right here. And when I hit enter, you'll notice that our controller manager, it will create the resource in the Kubernetes API, and our controller manager, which has a watch for those resources, will start to write log lines because it's recognized that it's there and it's going to create the necessary resources in response. So you can see the log output, and you can see that it's now creating these various resources. We have the 3 replicas of our front end. We have 2 Redis followers and a Redis leader, and those are all coming up as we speak. If I run kubectl get ns now, we have our guest book application namespace, and I can also get services in that namespace. Guest book application. We can see that we have services. We have our front end service, which is a service type load balancer. So if I was running it in the cloud, this would spin up a load balancer for me. Redis follower, Redis leader. So I mentioned earlier that we've generated the source code for a working Kubernetes operator. And as you can see, it will create all of those resources. But I want to clarify exactly what I mean by a working Kubernetes operator. What we get is the create, update, and delete functionality, or what I call the foundational functionality of this Kubernetes operator. So that means we can use this resource to create an instance of a guest book. We can use it to update an instance of a guest book, and we can use it to delete an instance of a guest book. What that gives you is a great foundation to build additional features that are commonly found in Kubernetes operators, like update functionality or even failover functionality, backup and restore functionality, all that good stuff. So what we've seen so far is that we can create guest books using this custom resource. So next, let's just take a look at updating it. So let's say that we want to change the number of guest book replicas from 3 to 2 because 3 is unnecessary. So I'm going to write that change to disk and then kubectl apply that same guestbook resource. And what you'll see when I do this is the controller will pick that up. It will update our deployment resource, the front end, and you can see that it's already terminated that one pod, and we now have 2 running instances. So there's our update functionality. And lastly, let's look at the same thing, but we're going to run delete this resource. And actually, our controller manager will not perform this functionality. What it has already done is it has assigned these resources as owned by this guestbook resource. So without our controller manager having to do anything, once we delete this resource, the Kubernetes API will automatically delete all of the other resources that are owned by our guestbook. So I'll run delete, and you'll see that our controller just is unable to fetch them because they're now gone, and the Kubernetes API is terminating everything, including services. No services left, and shortly the namespace will be gone too. You can see that it's terminating as well. So that's the create, update, and delete, the foundational functionality. So I'm going to stop our controller over here and close this file. Now I'm going to come back around and circle back to those configurations in the source directory and take a look at how we generated all that source code. Because as you see, we created a working Kubernetes operator without writing any code at all. So let's see how we configured that. Again, all the files that we're interested in are in this .source directory. So let's just take a look at them. All right, so these obviously are just regular Kubernetes manifests. This one here is from a deployment. And you'll notice that we have these commented operator builder markers throughout them. And what they mean, what they are is indication or instructions for operator builder on how to build our custom API. So in this example, you'll notice that for our front-end deployment, we had a field in our custom resource. And let's just open it up so we can refer back to it. We had this field of guestbook replicas that we could configure and use to change the number of replicas for our guestbook front end. And this is the deployment that defines our guestbook front end resource. And we're able to change it because we've told Operator Builder that we want a field in order to manage that. So every time you see a commented Operator Builder marker, such as the namespace, that means it's a configurable value. It'll show up as a field in our custom resource, and we'll be able to manipulate and manage that field through our guestbook resource. And so you can do this with any workload that you want to run in Kubernetes. You can just take the static manifests that you can use to deploy it, and here's the service for the front end. Here's the namespace. Here's the deployment for the Redis follower. Here's the service. Here's the Redis leader deployment and service. And you can add these Operator Builder markers to any Kubernetes manifests and then use Operator Builder to generate the source code for a Kubernetes operator to manage it. And so then the last piece of configuration we have is this standalone workload, which is an Operator Builder specific configuration file. And you can see it has a few different sections. The one at the end here, the resources section, it lists out all those files that we just looked at, those Kubernetes manifests that define all the resources that we need to spin up an instance of our guestbook application. So that's why when we ran Operator Builder commands, we just had to pass it this file, and it in turn references these files, these resource manifests. And Operator Builder then uses this list of resources, it consumes it, and uses it to generate the source code for all the objects that we need to manage in the source code. Besides that, we have this API block, and it contains various attributes of the custom API that we want to build, including the guestbook kind, which determines this value right here. And you'll also see fields in there that determine the API version as well that we use in that resource. And you'll also notice that we cluster scope this we've got cluster scoped as true, which means that our guestbook resource will be a cluster scoped resource, which we need to do in this case because we were creating namespaces for the application instance to be deployed into. If we were not deploying namespaces and the operator was just deploying instances of an application into an existing namespace, you could use a namespace scoped custom resource in that case. And then we have this section for a companion CLI. I'm not going to demo this right now. I'll save that for another demo, but that companion CLI could be used by, for instance, developers of the guestbook application as a convenience when interacting with the operator. And I'll show you how that works some more later on. But for now, that's the end of the demo. I hope you found it helpful. Thanks very much.